So again, we're going to skip the warm-ups just so that we can get through the lesson. They were just a review of stuff we already know how to do in terms of our logarithms. But today we're looking again at the natural logarithm, which, remember, this one looks different. It would be written ln x, which stands for natural log of x. And it's really just a log with a base e. They just don't write it that way. We just use the ln notation. And remember, e is like pi. It's an irrational number. It's a constant, approximately 2.71828. And we're going to be using that a lot today in the calculator. So just so you're aware, on the calculator, the e to the x, but there's an e button over here that you can access by pressing second and the divide sign. Today, though, we'll be raising e to a power, like e to the second, e to the eighth. You can also press this button down here, second ln, which makes sense because we're doing a lot of stuff with natural logs. It'll get you e to the power, and then you could just put in, for instance, e to the second power. So here's an example of the graphs, just so you can see what they look like, because we did graph logarithmic functions and exponential functions. This is the e to the x and the natural log of x, and you can see that they are indeed inverses. They've been reflected across the line, y equals x. Okay. We're not going to be graphing any of them, but just so you see what they look like. So examples 1 through 4 are actually a review of stuff we've already done. They want us to write each expression as a single natural logarithm. So we are going to be using our properties. So our quotient property, power property, and product property. So what would I do first for number 1 to start writing this as a single logarithm? Emily?
Put 2 as an exponent and 12.
Good. Move 2 back to a power of 12. So that would be the natural log of 144 minus the natural log of 9. That's using our power property. And then what would I do? Divide them. Good. I see subtraction of 2 logs. The quotient property says that I can divide those. And I should just get the natural log of 16. The next one, same thing. We take our 5, move it back up to the exponent. So this would be the natural log of 2 to the 5th, which is 32, minus the natural log of 4. So we divide those and get the natural log of 8. Again, when you read this, you can say ln, but normally we say natural log of 8. You were saying that loud. What would number 3 be? Natural log of x to the 3rd y. And if you want, you can put parentheses around that just to make sure you know it's grouped. And then how about 4? ln 3x to the what? 1/4 power. If you want, yes, we need to put parentheses around that. Or we could have written it with a root 2. So we could write it as the natural log of the 4th root of 3x. One of those 2 answers. Very nice. So what we're going to see, some of these properties will get involved into equations where we will have to combine them to a single logarithm, and then we will be able to solve by rewriting in exponential form. Okay, so just like yesterday when we saw the log, we would add in a base 10. Since this is a natural log, we're going to add in a base e. So it's log base e of 2x minus 4 to the 3rd equals 6. So now we're going to change this back to exponential form. So we'll take the base of the exponent, raise it to what's on the other side, 6th power, and set that equal to what we were taking the log of, which is 2x minus 4 cubed. And then you just have to solve for x. So I would need to undo the cube with a cube root. Remember your properties of exponents. If you're taking the root of something being raised to a power, we just divide those. So So this would just be e squared. And then the cube and the cube root undo one another. Now, e to the second power, when you type that in your calculator, is going to get you a big long number. So I wouldn't type that in now, I'd wait till the end. So just leave it there and use your inverse operation. So I would add 4. Then I would divide by 2. And then this is going to go into our calculator. If you want to type the whole thing in, you will want to group the numerator because it has a plus sign, indicating that those operations need to be done before division. So we would have parenthesis. Again, to get the e to the second button, you would press second ln to get our e to the caret. We'll put in our 2. Make sure you close the parenthesis to stop the exponent before you add 4. Close my parenthesis to stop my numerator and divide by 2. So I should get 5.6945. We'll just keep with the 4 decimal places like we did yesterday, just to be consistent. Okay, number 6, very similar. We're just going to throw in our base e. Change this to exponential, e to the 0.1 power equals x. And that goes straight in your calculator. That's it. You could change this to the 1/10 power, but you're going to have to use your calculator for the e button anyways. So 1.1052. Since we're a little short on time, which one do you want to do, 7 or 8? 8. Okay. So again, we are going to rewrite an exponential form, so we have to add the base e in. Remember, when these start getting mixed up, if it's a log with nothing, it's base 10. If it's a natural log, it's base e. So this will be e to the 12th equals x plus 2 divided by 3. How would I solve for x? What do you do first, Lainey?
Multiply by 3 on each side.
Very good. I'll multiply by 3 on each side first. Again, I would not reach for my calculator yet. I would just leave this until the end. And then last thing I do is undo addition with subtraction. And then this is going into my calculator. So we'll have 3 times. Second ln gets my e to the 12th button. Close that parenthesis, and then we'll subtract 2 at the very end. I do want you to try all of this on your homework. Make sure you're not just going to the answer key and writing down the answer after you do this work, because a lot of you will get all the work right and you'll type it in your calculator wrong. So I want you practicing to make sure you know where the parentheses go, etc. So we should get 488,262.3743. You can check these also. You can take this number and plug it back in here and type this in your calculator and make sure that you get 12. Now, sometimes we will round this, so then it might be like 11.999, but you'll realize that it's pretty close. You could also use the store key from yesterday to check your answers. I'll show that tomorrow when we're going over the homework. I'll show you how you can check them with your store key. All right, now the rest of the problems are not natural logs, they're exponentials. Okay, so just like we solved our exponentials yesterday, we would take the log of each side and then solve. We're going to do that again, but we're going to use the natural log. Okay, now before we do that, we do have to isolate the e to the x power. Okay, so step 1 is going to be to isolate e to the x power using inverse operations. When I say e to the x, it might be e to the 5x, e to the 3x, but you just want the e by itself. So I would start off by undoing addition with subtraction. Then I would undo multiplication with division, because you can't take the log of both sides until you have that base by itself, that e. Now that we've isolated it, we will insert and we'll take the natural log of both sides. This will become natural log of e to the 3x equals natural log of 3.2. We'll use our properties of logarithms to use the power property. To move that 3x out front. And then we'll just use inverse operations to solve for x. So I see multiplication of 3 times x times natural log of e. So all you'll have to do is undo multiplication with division. I will divide by 3 and the natural log of e. And you'll want to group those. And then this will go into our calculator. Again, make sure you close your parentheses after the 3.2. And we should get 0.3877. Now, as a shortcut, the natural log of e is going to come up a lot. The natural log of e is actually equal to 1. And you can test it in your calculator. We could prove it algebraically as well. But every time you have the natural log of e, that is 1. So if you want to, 3 times 1 is just 3. That'll save you a couple buttons that you have to press in your calculator. So if you prefer that, it would save you a little bit of time. We're going to skip 10. I will put the video on my website for 10 in case any of you want to see it. But the word problem will also teach how to solve another one of these, but just with the word problem involved. And there will be one like this on your test Friday, so I put a couple of these on our review tomorrow as well. Bless you. So it says the formula A equals P times e to the RT power, which is often referred to as the PERT formula for obvious reasons. Okay. Can be used to find a loan's future value A using the initial deposit P, the interest rate R, and the time in years T when the interest is being compounded continuously. Okay, so what that means is that you're putting money in an account and the interest is accruing like every second continuously. So it tells me an initial investment of $200 is worth $315.24 after 7 years. Find the interest rate. So you want to go through and decode what is what. So 200 would be A, P, R, or T? P. Initial investment. So P is 200. 315 would be what? A. 7 years would be time. So we are asked to find what the R variable is. Plug those into your formula. So 315 goes in on the left. 200 goes in for P. This is E. The RT, those are both exponents. So if you want, you could put parentheses. And we're going to solve this by taking natural logarithms. Okay, now before we do that, we do need to isolate, just like we've set up here off my screen, we need to e to the x by itself. So I have to get this by itself, so I'll undo multiplication of 200 with division of 200. And when you do that, you don't want to round that number you get. It's not a ton of decimals, but you need to write them all out. So when we divide this, we should get 1.5762 equals e to the 7r power, or r times 7 power. Again, to solve for something that's in the exponent, you have to use logarithms. And since this is an e problem, we use the natural logarithm. So we'll take the natural log of each side. Use the power rule again to bring that 7 out front. So we'll have the natural log of 1.5762 equals 7r times the natural log of e. Again, natural log of e is 1, so if you want to get rid of that and just put 1 there, you can. So really, to solve for r, you just have to divide by 7 on both sides. But again, if you don't trust that and you still want to put ln e in your calculator, because some people do, just to be safe, you can. So we'll put that in. Natural log of 1.5762 divided by 7, or 7 ln e. So we get 0.06500. Okay. Now you do have to change this back to a rate. This is a decimal at this moment. So we have to change to a percent by moving the decimal 2 spaces over, or multiplying by 100. So this is a 6.5% interest rate. Okay, let's go through the closure real quick too. I think we can fit it in. An initial investment of $200, that would be my P variable, is now valued to be $254.25, which would be my future value, A. Now, when they give you an interest rate of 6%, you have to change this to a decimal. Okay, so R is going to be 0.06. Remember, to change to a decimal, you either move the decimal 2 spaces to the left or divide by 100. Then we plug into our formula. So we would have 254.25 equals 200 times e to the 0.06 t power. And we'll solve just as we did the last one. We'll isolate our e through inverse operations. We'll divide by 200. And we'll get 1.27125. Again, do not round that, okay, because then it'll drastically round the rest of the answer. Take the natural log of both sides. Use your power property to move this out front. So that would be 0.06t times the natural log of e. Again, natural log of e is just 1. So I really just need to divide by 0.06. And since it didn't tell me to round, I'll just round to the nearest year. So we should get approximately 4 years. Okay, homework is on the website. Oh, there's a typo in the homework. It says to do numbers 13 through 29 odd. 13 isn't on there, so you're not doing 13. You'll do 15 through 29 odd. So just do the circled questions.